Hey Patriots, so in this video what we're going to talk about is similar polygons and how we determine if polygons are similar, and then how to write and read a similarity statement. Very similar to a congruent statement from semester 1, but now it's similarity and not congruence. So we're going to use the word in proportion a lot. And what does that mean? Well, it means if two things are in proportion, their measurements will make an actual proportion. So when we set up our proportion, so what we're going to end up doing is we are going to end up taking like two side measurements, and I'm going to do a long side of one shape, and I'm going to do a long side of another shape, and that needs to equal the short side of the first shape over the short side of the second shape. So on top, how I set this up, what matters when we set up these proportions, it really doesn't matter what the first fraction says, long over long, short over short, but what matters is that the second fraction matches the first fraction. The second fraction must match the first fraction. So my second fraction must match the first fraction. It has to, because if they don't match, then I can't tell if they are in proportion. And I'm going to show you what I mean. We'll talk about more of that in class and later in this video. So what makes these polygons similar? Okay, these are two similar triangles. For polygons, any polygon, triangles, rectangles, squares, trapezoids, pentagon, hexagons, I don't care. We need two things to happen. We need the corresponding sides to be in proportion, and the angles of the one shape have to be congruent to the angles of the second shape. So what I mean by the sides in proportion, this is what we're talking about. Well, how we are going to set this up. Hold on. Thank you for that. I just had a huge sneezing fit. Now, we're talking about proportional sides. When we do proportional sides, what we're going to say, we're going to start with left, and we're going to go over right. When we make our fraction, I like to write left over right. I can write right over left, but that to me, that's just weird. And when we do our sides, now this is important for our sides. For our sides, I am going to do long side on the left over long side on the right. And that is going to equal the middle length on the left over the middle length on the right, and that needs to equal the short side on the left over the short side on the right. Now, if all three of these fractions are the same, then my sides are what we call in proportion. So this is what we're checking. We're checking that our sides are in proportion. So let's look at the left, our left shape. What we want to find is we want to find the longest side on the left. Boom. And then we want to find the longest side on the right. So to show that these are in proportion, I'm going to do the long side on the left, and I'm going to put that over the long side on the right. And then that needs to equal the same fraction as the middle number on the left over the middle number on the right. So 10 is the middle number, and 15 is the middle number. So left over right. And then we're going to do short and short. And all three of these fractions need to be the same value. If they're not the same value, they're not similar. It's okay that they're not the same. We would just say that they are not similar. Now, if you look at these, come on, let me see if I can scroll down here. When we look at these, let's reduce these fractions. 18 over 27. I can divide both of those by 9 and get 2 over 3. 10 over 5. I can divide both of those by 5 and I can get 2 over 3. I can divide both of these by 4 and again I get 2 over 3. Notice it's the same fraction every time. That means the sides are in proportion. All my sides are in proportion. So if we could also do it with letters. So green over yellow, AC over DF equals CB over FE equals BA over ED. And then we would see are my sides, my angles, are the angles congruent? So please make your notes a little neater than mine. We need the angles to be congruent. So if you notice, angle A has one tick mark. That is congruent to angle D. Angle B is congruent. It has two tick marks at the top. It is congruent to angle E, two tick marks at the top. And then angle C, which has three tick marks, is congruent to angle F. So these two sides are similar. They're similar because their sides are in proportion. They make the same fraction, 2/3, 2/3, 2/3. When I go long over long, medium over medium, or middle over middle, short over short, and all the angles are congruent. These triangles are in proportion. And because they're in proportion, we are going to write a similarity statement. So this is just like my congruent statement, except we're going to use this tilde, this single squiggle, and that means similar instead of congruent. So if you look back at that last diagram, we would say triangle ABC is similar to triangle DEF. So my triangles are similar. So the sides are in proportion and the angles are congruent in that order. What do I mean by that? Well, let's read this similarity statement. So if we're given this similarity statement, let our congruent angles and our proportional sides are always by the order of the angles. Now I'm going to start with my sides. And because it's similar and not congruent, if you can hear that, I'm sorry, that's the dogs, they're playing. We're going to make fractions. So we always write it left to right, left on top, right on bottom. So GE is my first side, that goes over MA. And then I've got EO over AT. EY, notice I start with the letter I left off with on the one before it, TH. And then I wrap around. Y goes back to G and H goes back to M. All those fractions are equal to each other. So what we're going to end up doing is we're going to pick two and work with just those two. And then, of course, my angles are all congruent in that order. Angle G is congruent to angle M. Angle E is going to be the same as angle A. Angle O is going to be congruent to angle T. Angle Y is congruent to angle H. Boom. And then two more things to talk about. Similarity ratio. When we take those fractions that we just wrote, long over long, short over short, middle over middle, when we look at these similar triangles right here, notice, remember we got the number 2/3? Remember when we got the numbers 2/3? That 2/3 is what we call our similarity ratio. So when we write our sides out, so we do long over long, and we got the next middle over middle, and we've got short over short, whatever that fraction reduces to, that is called my similarity ratio. It compares the lengths of the sides on top of the fraction to the sides on bottom of the fraction. So that's my ratio, 2 to 3 in that first case that we did. Now, you may have heard this term a lot, scale factor. What scale factor does, if my similarity ratio is 2/3, my scale factor, which we use the number K, the letter K for, is going to be 3/2. We just take the similarity ratio and we flip it upside down, because what we're going to use our scale factor for is we're going to multiply the first figure by my scale factor to get the lengths of the second figure side, or a similarity ratio would be used with a proportion. And if my scale factor, like that first sentence says, if my scale factor is between 0 and 1, so is between 0 and 1, this is pretty much going to be a fraction. If it's a fraction, we've got a reduction. We're going to start big and go small. And if my scale factor is more than 1, we are going to start small and go big. It's going to be called an enlargement. All right, so this is a great starting point for what we're going to talk about in class. I know this was a little bit of a longer video, but there's a lot of terms to get through so we can do our homework, our assignment, and our practice in class. If you have questions, Patriots, make sure you ask your teacher. We'd love to help, and we will see you when we see you, Patriots.